Question 14, Part C, Part 1. Explain why the equation inverse tan of 3x plus inverse tan of 10x equals theta, where theta is greater than negative pi and less than pi, has exactly one solution. The functions y equals inverse tan of 3x and y equals inverse tan of 10x are both monotonic increasing functions, and hence one-to-one. That means both functions pass the vertical and the horizontal line tests. Considering the derivative of inverse tan of kx for some value of k that's greater than 0, we get k over 1 plus kx in brackets to the power of 2. Now the derivative is positive for all real values of x. And that explains why inverse tan of 3x and inverse tan of 10x are monotonic increasing. Now the sum of two monotonic increasing functions is also monotonic increasing and one-to-one. Now given that inverse tan of kx for some positive value of k is greater than negative pi over 2 and less than pi over 2, also given the fact that it's monotonic increasing, then the sum of the two functions, inverse tan of 3x plus inverse tan of 10x, must be greater than negative pi and less than pi. And because this is monotonic increasing, the horizontal line y equals theta must intersect with the graph y equals inverse tan of 3x plus inverse tan of 10x exactly once, where theta is a value greater than negative pi and less than pi. Therefore, the equation inverse tan of 3x plus inverse tan of 10x equals theta has exactly one solution, where theta is a value greater than negative pi and less than pi. Part 2. Solve inverse tan of 3x plus inverse tan of 10x equals 3 pi over 4. Let A equal inverse tan of 3x and B equal inverse tan of 10x. Taking the tan of both sides of both equations to isolate the 3x and the 10x, we get 3x is equal to tan of A and 10x is equal to tan of B. And the equation inverse tan of 3x plus inverse tan of 10x equals 3 pi over 4 can be expressed in terms of A and B. Since inverse tan of 3x is A, inverse tan of 10x is B, so we can write the equation as A plus B equals 3 pi over 4. Taking the tan of both sides of that equation, we get tan of A plus B, so this is the sum of two angles, or the tangent of a compound angle, is equal to tan of 3 pi over 4. Now tan of 3 pi over 4 is an exact ratio, we get negative 1. And expanding tan of A plus B, we get tan A plus tan B over 1 minus tan A tan B. Now recall that tan A is equal to 3x and tan B is equal to 10x. So we can express the left-hand side of this equation in terms of x. So tan A is 3x, tan B is 10x. So the equation becomes 3x plus 10x over 1 minus 3x times 10x is equal to negative 1. Now 3x plus 10x is 13x. 1 minus 3x times 10x is 1 minus 30x squared, and that equals negative 1. And by cross multiplication, we form the equation 13x is equal to 30x squared minus 1. Rearranging this equation here to form a non-monic quadratic equation, we get 30x squared minus 13x minus 1 equals 0. So using the quadratic formula, we get x is equal to 13 plus or minus the square root of negative 13 in brackets squared minus 4 times 30 times negative 1 over 2 times 30. And we get these two solutions. We get x is equal to negative 1 over 15 and x equals 1 over 2. But if you recall from part 1, for any given value of theta, there is exactly one value of x that will map to that value of theta, since the function y equals inverse tan of 3x plus inverse tan of 10x is monotonic increasing and one-to-one. So out of these two solutions, only one of them will be valid and correct. So we need to test both of those solutions. Now when x is equal to 1 over 2 or half, inverse tan of 3 times 1 over 2 plus inverse tan of 10 times 1 over 2 equals 3 pi over 4. So that's correct. And when x is equal to negative 1 over 15, the value of inverse tan of 3 times negative 1 over 15 plus inverse tan of 10 times negative 1 over 15 is approximately negative 0.785, which is certainly not equal to 3 pi over 4. So this solution here is incorrect. Therefore, the only solution is x equals 1 over 2.